All right. Good morning, everyone. Great to be here. Let's begin. So, that was a great intro. And my name again is Avi Itzkovitch. I'm from Israel. I'm a UX UI designer, and I'm also an organizer of a conference which will be in Israel about user experience design, which is called UX Salon. But today, I want to talk to you about adaptive design. Now, the word adaptive design has many parallel expressions. For example, proactive design and context-aware computing, I heard. Also, curated experiences. These are the types of terms I've been hearing a lot in the past year. But for the purpose of this talk, I'm going to call this term adaptive design. So, if I stopped my presentation right now, some of the best minds in this room would probably ask me, Avi, what is adaptive design? And I will answer. I will say that, in computer science, the term adaptive design refers to a process in which an interactive system changes its behavior according to the context of use. So, in other words, responsive design means that the interface changes according to the screen size and resolution. But adaptive design means that the interface and the experience change based on the individual user, based on the context of use. So let me give you an example. Imagine you're at home using a mobile device. You use a Gap app to search for latest fashion. You want to find a t-shirt you want to buy or shoes you're interested in. This is the experience we're all familiar with when we use a mobile device. But what happens if you walk out the house, you have the phone in your pocket, and you approach the Gap, right? And you enter into the Gap. You can get a push notification, you get a message. Hey, welcome to the Gap. Would you like some assistance? And of course, if you tap yes, it would be the same mobile application, but a completely different experience. It will be a personal shopping assistant. So, it will welcome you. It will say, hey, hello, Avi, welcome to our store. Now, we know which store this person is at. We have the GPS sensor, and we understand the context. So we will ask him, the shoes you wanted to buy, just find them on aisle 3 on the left. And the t-shirt you wanted, get 20% off just for visiting our store. So again, we understand the context of use, we understand who the user is, and we welcome him walking into our store. That's adaptive design. We adapt to his context. Now, for some of you may remember this movie, Minority Report. Tom Cruise, the actor, walks into the Gap. His retina is scanned, and they identify him. They know who he is. And I think it brings up this question, and the question of privacy and ethics for some of you. What kind of a world would we live in if everywhere we go, they'll recognize us, they'll scan us, they'll identify us, and they will change the experiences, change the environment around us based on this information? I want to say that today, this is an important question, the privacy question, but I'm not going to touch this question at all. You may feel uncomfortable throughout my presentation today, but I want to say that I'm just a messenger. I'm just going to show you the technology. If you want to talk to me about privacy and ethics of all this technology after, I'm more than happy to talk to you about it. So back to this. Tom Cruise, the actor, walks into the Gap store, and his retina is scanned. Now, this movie was shot in the year 2002. 2002, the director, Steven Spielberg, was trying to imagine a future that, you walk into an environment and you are recognized. And the best thing he could think about is a retina display, a retina scan that identifies a person. That's the best he could ever come up with at that point of time. And I say to him, we don't really, we know today that you don't really need a retina scan, you don't need a biometric scan to identify a person in a digital environment. All you need, really, is a tracking device called Purple 2. What's Purple 2? Well, for that, to explain that, we have to go back in time. And to go back in time, I brought with me the time tunnel. This is Doug and Tony from the classical television show, The Time Tunnel. And we're all going to go back in time to the year 2007. So, you're welcome. You ready? Okay. And let's go back in time. And Welcome to the year 2007. My name is Avi, I'm an engineer. I work for a company, and we're developing this tracking device. We call it Purple 2. This tracking device has computing powers. It has advanced sensors. It has a connection to the network, not just any connection to a network, a wireless connection to the network, because we want to track wherever you are 24 hours a day. Would you carry this device in your pocket? We'll give it to you for free. Now, if I said this to you in the year 2007, in the beginning of 2007, you'd probably tell me that I'm a little bit crazy and you probably wouldn't carry this device in your pocket. But what if I changed the semantics a little bit and I said to you, I'm actually working for Apple, and Purple 2 is a code name for a project we're developing, which we're going to call the iPhone. Would you carry this device in your pocket if I gave it to you for free? I think the answer would probably be yes. These people are waiting in line to receive it, and they're going to pay a lot of money to buy it. So yes, what I'm trying to say to you today is technology, we carry it in our pockets. We carry these devices in our pockets. And these mobile devices know more about us than we care to admit. They know where we go. They know what our hobbies are. And they are a unique identifier that we carry in our pockets. There's no need for a biometric scan. We can identify a person walking into a store just with this device. So I want to give you some more examples of classical adaptive design in the wild. This is an original example I found, which is for a GPS device. A GPS device, this is the interface we see as we drive throughout the city. But at night, the interface changes. It becomes dark. And the reason it does that is because it's trying to maintain a safe driving environment for the user. Of course, it's a bright light. It's a device that shines a bright light in our face. At night, it's not very convenient. It's not very comfortable. Of course, it's not safe. So what it does, it automatically changes the interface based on the time and the location of the user. How does it do it? Well, it has sensors. It has a GPS sensor. It knows the location of the user. And whenever it becomes dark, the interface changes. It adapts to the user context to maintain a safe driving environment. So that's one example. Another example is Google Now. Many of you probably know this example, but Google Now is an app that shows you a series of smart cards that appear like magic. Wherever you are, whenever you need them, they appear. I'll give you an example. You could be standing at a bus station or a train station. The next type of information you probably are looking for is when is the next bus coming? When is the next train coming? You don't have to look. You just open Google Now, and the card appears. It understands the context of your location. Another example would be your next appointment. You have an appointment across town, and Google Now knows your calendar. It knows where you are. It knows the traffic condition. So if perhaps maybe there's a traffic jam on your way to the meeting, it tells you better leave the house now, so you're not going to be late to the meeting. It knows everything. It knows the context, and it helps you get to the meeting on time. So it's a smart card. And there are more examples of that. I recommend you check Google Now. Here is an app, a cover for Android. It shows you relevant apps based on your current location. So if you're at home, you get home type of applications, and the car, navigational, and at work, business type apps. So again, context based on location. And this is Mark Weiser. He's one of the forefathers of ubiquitous computing, and his quote, famous quote, says that the most profound technologies are the ones that disappear. They become a fabric of our life. We use them and we don't even appreciate how advanced technological devices they are. They just become a part of us. An example of this, ubiquitous computing, could be found in Alba. Alba is a smart light bulb that understands context. How does it work? Well, when you wake up in the morning, it wakes you up gently with your alarm. So the light goes up gently and you wake up fresh. During the day, you want to be productive. Alba shines bright light in the room. So you have more light to work, you feel more productive, more energized. At night, you want to relax, you want to eat dinner with your family. The light is different. The light temperature is a little bit more warm and more comfortable. And of course, if you wake up at night, Alba knows that this is the middle of the night, so it brings up the light very gradually, so you don't wake up completely. It's very pleasant to wake up and have just a little bit of light so you can see your way to the bathroom. How does it do it? Well, it has sensors. It has intelligence. It calculates the time and date, and all these sensors together with this computing power understands the context of use, and adapts to the user in real time. That's adaptive design. So I talk about understanding the context using sensors. But what is an adaptive sensor? Of course, a sensor is like a classical sensor, could be an accelerometer. Accelerometer is a device, a sensor we have in our pockets, so you can tell if a person is holding the device on landscape or portrait. But that's great, okay, but if we reappropriate this sensor data to understand if a person is walking or jogging or standing, then it gives us some sort of a context-related information about the user. So it becomes an adaptive sensor, or a sensor that enables adaptivity. So if we take sensor data and turn it into context, that's an adaptive sensor. It could be anything, any technological device. Here's a list of sensors I found on Wikipedia. There's lots of sensors here, and some of them are not relevant sensors to us, but if we use them, you can probably tell if a person is walking or if a person is in transport, if he's on a bus or on a train or driving. If he's driving, where is he coming from? Where is he going? When is he going to get there? You can tell if a person is indoors or outdoors. If a person is outdoors, where is he at? What venues are nearby? What's the time? Is he in a loud environment? Is he in a dark environment? We can understand that using sensors. We can tell if a person is entering a shopping mall or a supermarket, if a person is entering a place of business. But I want to focus for a moment on what we don't really classify as sensors, other devices, other technological devices that we can utilize to understand context. So a camera, of course, is not a sensor. It uses, to take photos. But if we reappropriate it to, for example, in a Samsung Galaxy, what they do is they use a face detection. So whenever the person is looking at the device, it prevents the device from dimming. You don't have to keep the device all the time if you're trying to read an article. It understands the context by recognizing your face. And of course, we can use camera to see if a person is in a light or dark environment as well. Another example of not classical sensor, but it's an adaptive sensor, is an email address. How is an email address a sensor, you may ask? Well, let's consider this for a moment. A person is, we're designing an app, and the first time a user is logging into the app, we ask for his email. And once he puts in his email, and right on the fly, we run this email through an API service that goes across all these social media websites, and it aggregates all the data they can find about the specific user. So then we can tell if a person's gender. What's the person's gender? We can tell the person's age, and we can tell the person's hobbies. So in this case, if it's a 30-year-old male or a 16-year-old girl, they could have a completely different experience based on just an email address on the first launch of the application. So an email could be an adaptive sensor. Time and date is an adaptive sensor because, of course, it gives us some sort of context on the use of time. For example, Songza, it's a mobile app that gives you songs you can listen to. But regardless of the time you open it, you get different options based on the time and date. So during Christmas, you get holiday songs. And if you turn it on in the morning, you get energizing songs. At night, songs that helps you fall asleep. So it really looks at the time and date and changes the experience based on that. Here's another example, cool example. The website changes based on your current location and current weather. So if the weather is different that specific day, they'll be wearing something else. And of course, it kind of recommends what to wear in the specific day based on the weather. So again, time and date is a very important sensor we should consider. The Internet of Things brings us a lot of challenges, a lot of interesting challenges when it comes to adaptive designs, because if we take sensor data, raw sensor data, it means nothing. But if we turn it into knowledge, if we turn this data into adaptive design, into contextual knowledge, then we can create all these conversations between these devices. So, for example, a Fitbit, which is a smart bracelet that looks after your daily activity and your sleep patterns. If this device would talk to Nest, the smart thermostat, and they will communicate between themselves to create a conversation, and they will find the optimum sleeping temperature. So I go to sleep and I feel good, and I wake up fresh. That's a conversation I want them to have. And then in the morning, as I wake up in the morning, they'll communicate with the smart kettle. So I wake up in the morning and I have fresh coffee, fresh hot water for coffee, right? That's the kind of conversations we're working on today to try to see how technology could help and aid users and create better experiences in digital environments. So again, if we take sensor data and turn it into knowledge, it's what I call contextual knowledge. Okay, so the next question, of course, is we take sensor data and we turn it into context, and then we adapt to users in real time. And the question is, what is context? What is context? Many people, when I ask this question, they say, well, context is the location of the person. But not really, because what does it tell about the user? What does it tell about his needs, his wants? Not a lot. So let's do this. Let's design together an app, a mobile application for a shopping experience in a supermarket, a personal shopping assistant. What questions we have to ask in order to create an effective experience for that specific user? What layers of context we need to understand in order to create a better adaptive design? So the first question we have to ask is, how much time is available for shopping? Is the person buying quickly just to go on his way to work, or is he buying the weekly grocery list? Does he have a lot of time or a little time? It's an important question. We have to understand that. Another question is, what's the time and date? Is it a holiday, or is it just a Monday afternoon? It's Boxing Day. What's the physiological and emotional signs of the user? Is the person happy shopping? That's another layer of context. Is he satisfied? And I think one way we can solve this issue is perhaps create a face detection. When a person is holding the device, we can see if a person, what's the physiological state of that person. Recently, iWatch from Apple has released, it has heart rate monitor at the back, so we can probably gauge if a person is excited or not during an experience like that. So these are two kind of ways to kind of gauge the physiological signs of a person. But I want to focus for a moment on research I came across from Dr. Yoram Kalman from the Open University of Israel. And he researches what he calls HCI markers, human-computer interaction markers, that what he says that if you track someone using a technological device over time, you can tell with a great degree of certainty certain physiological signs about the person. For example, if you track someone using YouTube for a month, you can tell if he has attention deficit disorder. Or if you track someone mouse tremors, perhaps he's an elderly, or has he's developing Parkinson's, or is disabled. So can you imagine in the future a responsive website will respond to the physiological signs of a person, and perhaps if it's an elderly person trying to access his bank account, perhaps then the interface will change and will create a better experience for him, bigger buttons and much better affordance for his needs. So HCI markers, interesting research. Back to context. What other layers we can decipher? What's the spatial environment? Where the person is at inside the supermarket. Not if he's inside the supermarket, we know that. But which products are nearby him? Walmart has created already an app that understands that you walked into the Walmart, and it asks you, do you want to go into store mode? And you get coupons based on your current location. But if we want to understand where the person is at in the supermarket, what aisle is he looking at? And today there's already technologies that are developing to tell if where the person is at inside an indoor location. iPhone is a company that develops a triangulation of Wi-Fi data to know where the person is at specifically in the store. I was in a demo and it actually works. Another emerging device is beacons, iBeacons. These are little transmitters you put inside your store. And the closest you are to one, then you get a message based on that location. So if you're close to one beacon, you get one message, and if you go close to another, you get a different message. So we understand the user location based on these little transmitters that you place inside your store. So if you think today that GPS is the word for understanding location, I say to you, think twice maybe, because I think in the near future, IPS, indoor positioning system, we're going to design for the indoor experiences as well. Cool. All right, what else we have to decipher? What's the intended use of the products the person is trying to buy? Is he trying to buy flour to bake a cake or to bake a bread? An important question. Maybe we can understand that by creating shopping lists based on recipes. Another question is, is the person shopping alone or with a partner? And we can create different experiences based on that. For example, imagine this scenario. You walk into a supermarket, you check in with your presence. You don't have to press any buttons. You just walk into the store, we know you're here. If you check in with another person that has the same account, maybe then we can split the shopping list. Maybe then you can go separate ways. In the United States, supermarkets are very big. You can get lost. And you can find yourself, you can orient yourself back in the center of the store when everyone gets the shopping list done. So that's very cool. And one more question. What is the general interest and preferences of that specific user? Does he prefer red wine or white wine? Now, how do we do this? How do we understand? What sensor is there to understand the general preference of the user? It's a tough question, but the easy answer, we use human behavior as a sensor. Because we are a creature of habit. If you track someone during his lunch hours, between noon to 2 every day, within a month, you can tell where he's going to eat his lunch tomorrow, right? We can do that. Moves is an iPhone app that tracks your day-to-day activity. Every day, creates a new timeline of what you've done. So you can tell, you were home, you walked for 8 minutes, you sat at a coffee shop, walked for 8 minutes, you were at work. Every day, a new timeline. What can we do with this data? Well, we can create a heat map of a person's life, where he likes to spend his time, where he likes to spend money, where he likes to spend time with friends. Again, privacy issue, but we're not going to touch that. Sensagon is a company that analyzes your social media correspondence, but it doesn't look for what you post, it looks for how you post things, what words you use. It has over 300 parameters to analyze and to create a psychological analysis of you. It creates a persona of the specific user, so you can tell if a person is the emotional user, you can create an emotional experience. Again, emerging technologies in this field. But if we want to know what preferences the user in the supermarket has, if he prefers red wine or white wine, we can use these club cards or loyalty cards or credit cards, and we can analyze the shopping patterns of the specific user and, of course, adapt to him. So we understand context. We understand the layers of context. We understand we can take sensors, turn it into context. But how do we design these experiences? How do we design what tools do we have to design these experiences? And again, simple answer. We use our own ability, our own senses to analyze and to create parallels between the digital and the physical world. So for example, in a loud environment, we raise our voice to be heard. In a digital environment, we raise the system volume. We add vibration, we add flashing lights, right? So this is the kind of parallels we can create. I want to give you another example for such parallel that you can find in Project Glass. Project Glass, of course, is Google. Now, 2 years ago, they came up with this video, a video that depicts a user through his eyes. It was a way to show what future glass would look like. Of course, this video has no relevance today, but I want to use it to kind of show how we can create these parallels. So imagine a person is wake up in the morning. This is how we see it in the movie. He wakes up in the morning, and we see it through his eyes. He looks up in the skies, he sees the weather, he sees the time, eats his breakfast, and gets a text message, goes out to work. Now he goes to the same subway stop. He goes every day to work, and he approaches the subway line, and he gets a message. Subway service is suspended. Don't go down. And what can you do? Well, he gets a message. You got a walking route. You're going to walk to work. And what is this person thinking? Wow, great experience? Maybe, but he's thinking, I'm going to be late for work. If they knew what subway line I'm taking to work, why didn't they tell me this when I was at home? And better yet, why not wake me up 20 minutes earlier? I'm going to be late for work. I mean, this is what we would do. If we knew that the subway line is suspended, we'd probably just set the alarm a little bit earlier ourselves. That's the parallel I'm trying to get. So if we had to redo this movie, probably it will look like this. A person wakes up in the morning, he gets a message. Good morning. We woke you up 20 minutes earlier. Guess what? You're walking to work. Okay, of course it's exaggerated, but that's the kind of, that's the example of parallels. Okay, so really what it comes down to is it's adaptive thinking. It's a mindset. If we understand that we take sensors and technology all around us to understand the user, understand where he's at, then we have it. We can do it. We can create adaptive experiences. So I want to give you two examples of how adaptive thinking helped resolve the design problem. And so for the first example, good news, we're all going to go on a romantic trip down this forest. And we're walking down this forest, and all of a sudden we see on our left this flower. It's the most amazing flower we've ever seen in our lives. And we want to take a photo. We want to share it with our friends. Hey, check out this amazing, what's the flower name? Problem. So if we're all here on this trip together, I'll probably ask one of you, does anyone know what the flower name is? And maybe not, because it's a hard question. So maybe we can turn to the books. If we have a book in the specific region we're in, we can carry it and look for maybe we can find it there, maybe not. What can we do? Then maybe we can go online. This is how I searched on Google how to find the flower name. I found these instructions. So I didn't touch it. It's exactly how it is. You have to pick up the flower, you have to take it home, you got to fill up a form. At this point, I'm pumped. I want to know the flower name. I pick up the flower and I go to my house. I sit by the computer, one flower in my hand, mouse in the other, and I'm going to have to read exactly these instructions because I want to be accurate and I want to fill up exactly the form the way it is. So I'm ready. I'm reading and I'm filling up the form and I'm reading, filling up the form, reading and filling, and 2.5 hours later, the flower is already dead. But perhaps we have results. Make sure not to press reset the form, otherwise you got to do it again. The question is, maybe you get results, maybe not, but the question is there another way? Could we do this differently? And my answer is yes. It's called adaptive design. How does it work? Well, we have too many flowers. This is the problem. We have too many flowers. How do we narrow down these results? Let's look at the sensor data we can collect. So, of course, we can ask, what's the flower location? GPS narrows down the results to 300 flowers. Type of soil. If we have an internet connection, internet is a sensor. We go out to the database and we analyze what soil is in the immediate location. Bloom month, time and date, sensor, 52 results. And then we have to ask the user something. We have to ask, what's the color of the flower? So that's the only interaction the person has. He opens the app, gets a question. What color is the flower you're looking at? Red. Taps on the red, and boom, 6 results. So we resolved the design problem using sensors and creating a search engine based on location and context. Another example, that's the flower name, by the way, if anyone wants to know. Another example is for bicycle sharing. Bicycle sharing is, of course, you can rent a bike, and many cities around the world allow this. So if we wanted to create an app for such bicycle sharing, this is something I did in Akshur very quickly, just an example. This is a type of interface you will encounter. It shows your current location. The nearest parking spot for bike rental has no bikes. You better go to the second one. And you tap on it, and you get some sort of dashboard. And that's great, right? This is an app we can close up, wrap up, send to the App Store, and gets a direction to where to go, and it works. How can we make it better? So in this case, we used adaptive thinking or adaptive design to simplify the user interface. Of course, when the person arrives to the rental station, the context has changed. Right now, he's not looking how to get to the rental station. Right now, he's looking to rent a bike. So perhaps then, we know where he is. Perhaps then he gets a button that was not there before. Rent a bike. So this is easy, right? This button appears as soon as you get to the current location. And now again, the context has changed. Now you're renting the bike. You don't want to rent a bike. You don't want to get to the location. So when you open the app, you get a UI that was not there before at all. This is the rental statistics. How much money and how long did you drive? This is the type of experience, based on context. This is relevant to the specific context right now. And of course, you want to return the bike. That's the most immediate need you have. And you have a big button, return the bike, and you get the parking spots, where you have available parking spots to return the bike with ease. So, if I ask you today, or if I ask you now, what is adaptive design? I'll give you the short answer. Adaptive design is getting what I want, when I need it, in my immediate context. And if I wanted to make it even shorter than that, I would say that adaptive design really is an invisible design. Because really, it's not about infringing of the user's privacy. It's not about collecting data and advertising better. It's really about creating better user experiences. And when the experience is transparent to the user, when these conversations happen behind the scenes, the user doesn't even feel it. He just enjoys using the app. The experience is better when it's invisible. So adaptive design, in my eyes, is really invisible design. If you want to read more about this, I wrote an article for Smashing Magazine, which is called Creating an Adaptive System to Enhance UX. I also have a group on Facebook. If you look for Designing with Sensors, I post interesting sensor devices on this group. It's a very popular group. You're welcome to join. Just look for Designing with Sensors. And if you want to continue this discussion with me, I'd love to meet each and every one of you here. My name is Avi, and I thank you for your time.